are talking about regression models. And regression is just analyzing change in X and Y to try to find a pattern. Once you find a pattern, you'll be able to write a model, which is just an equation. But something that's important to notice is that we can only work with patterns that are either adding or multiplying. If we want to talk about subtracting, we would just view that as adding a negative number. If we wanted to talk about dividing, we would just view that as multiplying by a fraction. And so, for example, if we were dividing by 2, we would just view that as multiplication by 1/2. If we were dividing by 3, we would view that as multiplication by 1/3. Okay, and so when you're analyzing your data, usually given as points or tables, you want to make sure your x's are always adding 1 each time. So in this column, I've put add 1 in all the columns. And then for a linear function, your y pattern will also be adding. If you are dealing with a linear function, you are going to use the linreg feature to get a y equals ax plus b equation. If you notice that your table is instead multiplying in the y column, that is going to be an exponential function. And so you will be looking for the expreg feature of your calculator, and your equation will be y equals a times b to the x. And for quadratics, we're looking at something called the second difference, which we will talk about. If the second difference is constant, you are working with a quadratic function, and then you would use the quadratic feature to get ax squared plus bx plus c. Okay, and so we are going to do this in the TI-83, 84 calculator, and these are the steps. Okay, and so I'm going to highlight the main steps, but you always press stat edit first, stat edit, and you're going to input your table into L1 and L2. Your x values go in L1, your y values go in L2. So stat edit, and then once your table is in, you're going to do stat calc, and if you want linreg, you're pressing 4. If you want exponential, you're pressing 0. And if you want quadratic, you're pressing 5. Something else I want you to add to your these notes is alpha trace. Okay, and so that's going to be for the store feature, store alpha trace. That's if you want to store the equation. Okay, and so looking at these examples, the first thing we want to notice is what kind of function it is. We have to identify the pattern. So my x's in this first example are going up by 1s, which is exactly what we want. And so now it makes sense to look at a pattern in the y's. Here the y's are also going up by 1. We are adding 1 each time. And so that means, I'm going to go ahead and write that here, we are working with a linear function. Okay, and so that means we want to press stat calc 4 to get our linear equation. So in your calculator, the first thing you have to press is stat edit. Stat edit. And then to clear your table, if you have something in there, highlight L1 and press clear, and then you'll have to press enter. And then in L2, press clear, then enter, and it will clear your table. My calculator, I don't have to press enter, but on yours you will. Okay, and so in L1, I'm going to type my x's, and then be careful and make sure you're using the negative and not the minus sign, and type your y's in L2. Okay, and so from there, you're ready to press stat calc, and calc is over to the right. And then option 4 says linreg. So you can scroll down to it, or you can just press 4. Okay, and where it says store regression equation, that's where you want to press alpha trace, and I always just store it in Y1. So alpha trace Y1, and then press calculate or enter on calculate. Okay, so you should see A equals 1 and B equals 4. Okay, and so for AX plus B, my equation is 1x plus 4. Okay, for the R squared and R value, we won't really be using that until our next lesson, but I'll tell you how to turn those on, and what they mean is they're just measuring how accurate this model is. An R value of 1 means perfect. And so if you're seeing an R value of 1, that means this is a perfect fit. This is perfectly linear data. Okay, so looking at number 2, let's first identify the pattern. My x's are going up by 1s, so it makes sense to look at the y's. My y's are multiplying by 3. Okay, that means we are working with an exponential function. Exponential goes with multiplying, if you look back up here. And so that means we want stat calc 0. Okay, and so same steps. Now you can go to your calculator, stat edit, go up to L2, press clear, enter, go up to L1. These are actually the same x values, so I'm not going to clear those, but you could do the same thing. And so 1, 3, 9, 27, 81. Stat, right arrow to calc, and then you can scroll to 0, or you can just press 0. And then scroll down to store regression equation, alpha trace, and then you could put this in Y2 if you wanted to, just so it's not in the same. This will be more useful next class, and then enter. Okay, once again, those R values, that means I have a perfect fit, but all we care about right now is the A and the B. So A is 9 and B is 3. And so since this is exponential, I'm writing A times B to the x. Okay, so that's up here in this table. So linear is ax plus b, exponential a times b to the x. And so stat calc 4, so we can get y equals ax plus b. Stat calc 0, so we could get y equals a times b to the x. And you can put the b value in parentheses if you want to, they're not necessary. Okay, in this next one, our x's are going up by 1. So now it makes sense to look at the y's. From -6 to 0, we're obviously multiplying by 0, so we don't want to look at multiplication in this situation, because if we were continuously multiplying by something, the rest of it would be 0. And so -6 plus 6 would get me to 0. -6 plus 8 would give me to 8. Then we're adding 10. And then we're adding 12. So clearly we're not adding the same number, so it's not linear. And we already know it's not exponential because it's not multiplying by the same number. But if you look at the differences of these red numbers, from 6 to 8 is 2, from 8 to 10 is also plus 2, and then from 10 to 12 is also plus 2. And so these numbers are called your second differences. Second differences. And if the second difference is constant, that means it's quadratic. And so here I'm just going to write second difference, constant, const. And so that tells us we are working with a quadratic function. Okay, and so from my table, I know from the table up here that gives you the directions, I know I need stat calc 5, and that's going to give me ax squared plus bx plus c. Okay, so in your calculator, stat, edit, that's always your first step, clear what's in there, so clear, enter, and then clear, enter. It's important to press enter or it won't clear it. Okay, and so now I can put in my table, which is 0, 1, 2, 3, 4. And then negative 6, 0, 8, 18, and 30. And then stat, go to calc, press 5. I'm going to skip storing for now. And then A is 1, B is 5, and C is negative 6. And once again, R squared is 1. That means it's perfect. And so I can write my equation 1x squared plus 5x minus 6. And then often we'll leave the 1 invisible. So if there's not a place to like type a coefficient and you're just trying to identify the equation, it would probably just say x squared. Okay, and so I want to skip to one where they're just giving you points. If they're just giving you points, put those points in a table. I think it'll make it easier to identify the pattern. Okay, and so my first point, 0, 8, and then I have 1, 3, and then I have 2, negative 4, 3, negative 13, and then 4, negative 24, and then 5, negative 37. Okay, and so it looks like my x's are going up by 1 each time. And then notice we go from positive and then consistently negative, and so I know it's not multiplying by something. It would oscillate from positive to negative, and so I'm going to try the adding pattern. Here we're subtracting 5, and then we're subtracting 7, and then we're subtracting 9, and then from negative 13 to negative 24 is subtracting 11, and then we're subtracting 13. So clearly not linear, but if we do the differences of the differences, that's the second difference, I can see I'm subtracting 2, from negative 9 to negative 11, I'm subtracting 2, and subtracting 2. So once again, our second difference is constant, and so we know this is quadratic. Okay, and so then that tells you want stat, calc, 5 to give you ax squared plus bx plus c. So go to your calculator, stat, edit, go up and highlight L2, clear, enter, L1, clear, enter. And then we can type our table. And then stat, calc, option 5, and then you can go down to calculate, and then I can see that my A value is negative 1, my B value is negative 4, and my C value is 8. And so my equation, you can leave the 1 invisible and just write negative x squared minus 4x plus 8.